Hello. So, this video we are going to be going through condensing and expanding logarithmic expressions. So the idea is that we could have some sort of large argument inside a log, some beastly thing that looks terrible, and we can break it apart into lots of little pieces. Or sort of conversely, if we have a bunch of little pieces, we can collapse them down into one big log argument. As to why we want to do this, there's actually a lot of reasons why this is useful in various contexts. This is something that will come up as like a whole section in calculus, for example. It's also very commonly used in computer science because it turns out computers are better at adding than they are at multiplying in a lot of ways. But for right now, this is sort of a fairly mechanical skill that we're going to be trying to sort of walk our way through. Okay, so with that in mind, let's look at an example. Now, we have here log of some terrible thing, right? Like we have this big expression. Now, there's two ways that we could sort of tackle taking this on and trying to break this apart, right? So here we're going to try to expand the log, meaning that we're going to try to break this into a lot of little pieces. The first thing we could try to do is we could try and simplify all of the stuff inside. And this isn't like a terrible way to go if you see a lot of things that could cancel out, or if there's a lot of stuff that could factor and that kind of thing. As it turns out, with this particular problem, most of that stuff is already done for us, so we don't really need to worry about doing a lot of that simplifying down. The other way, and you can do this either after step one or instead of step one because it'll sort of work its way through, with the little asterisk that you do want to factor stuff because that if you don't factor things, you won't sort of see how to cancel stuff later. But in terms of canceling sort of like factors and that kind of thing, it would make your life easier to do it beforehand, but if you don't, it's not a huge deal. So once we've sort of whittled it down, or if you decide not to go that route, it's sort of more work, but it'll still get you there. Next step is to use the log properties to basically break this thing apart as much as you can, and then maybe simplify stuff at the end if you didn't cancel everything out sort of at the beginning part, okay? All right, so we're going to walk through this particular problem and see how that works. So we have this log expression of this bunch of stuff that's being multiplied, and we're going to use three, which is really sort of two, but three of the log rules in particular. So we want to follow sort of these following properties. We want to use these to break it apart. We're going to use the log of the division is going to be the difference of the logs. Then we can use the log of a product is the sum of the logs. And we can use the log of something to a power is, right, move the power in front, that power times the log of the original thing. Now, the particular order you use these in isn't a huge deal, but it is almost always easiest to do it sort of in the order that I happen to, unsurprisingly, put them up here. Meaning that the very first thing I'm going to do is do the division part because, again, I have sort of this big expression here, but it's really sort of the numerator like craziness and the denominator craziness. So I'm going to split that apart. That way I'll have the log of all of the top minus the log of all of the bottom, right? So using that property, I get this big beast. Now, be very careful when you have this negative over here because this thing is going to get distributed. So you want to make it you want to be very careful about using parentheses and such when we're dealing with the second part to make sure that we sort of keep track of what needs to have that negative like distributed to it afterward. Now, next up, we're going to use that product one. So we have now, right, the log of a bunch of stuff being multiplied, and we have over here a log of a bunch of stuff being multiplied. So I'm going to use that product breaking apart as sums and break apart both of those pieces. So this top part, the x squared, x plus 1 cubed, all of this stuff, that becomes all of these sums, right? So I have x squared, and now I have plus log of this next factor, the x plus 1 cubed, plus log of this next factor, y minus 3 squared, etc. And then, again, be careful here with this negative. So I'm going to have minus, then I'm using here a bracket. You can use parentheses, whatever you want. But I'm going to have a minus, and then all of this stuff is added together because I'm breaking up this product the same way, right? So I have log of z cubed, and then this had times x minus 6 to the minus 3. So now I'm going to have plus log of x minus 6 to the minus 3 plus, right, et cetera, et cetera. But then this negative is going to get distributed against all of this eventually. That's why I want to be very careful that I keep track of that negative. Okay? It's like the biggest sort of source of error for most of this. All right. So next up, we're going to use that third property. Log of a to the b means I can take that power in front. And the idea is that I'm going to take all of these powers, like this x squared, I can put the 2 in front, right? The cubed over here for the x plus 1, I can put the cubed in front, etc. So doing that, I notice, right, that I have now the x squared became 2 log of x plus 1 cubed became 3 log of x plus 1, etc., etc. And the sort of nice thing about this is if I look at each of these terms now, they all became what we call linear terms, meaning that they're all just x to the something, like x or x plus 1 or y minus 3. We have a lot of these sort of linear terms. So they're sort of, in some sense, becoming fundamentally easier things because I'm not now worried about, x to the third or x squared or something. I have just x, and then that power became a coefficient. Last but not least, I need to actually, as I keep saying, worrying about this negative, right? So now I'm going to distribute that negative. So that negative distributed, right? So I got the minus 3 log z. This minus 3 became a plus 3. This plus log becomes a minus log, etc. Right? So make sure I very carefully distribute all those negatives. Okay? So this is the process of expanding logs. Now you could look at this and be like, that seems like a lot of work, right? And that seems like it's not a whole lot simpler. And that's a totally fair sort of argument to make. Which one of these is the simpler expression is more about what you're trying to accomplish than it is about sort of declaring one being the more simplified form, okay? So with that sort of in mind, we can also go backwards, right? So if I want to condense a log expression, meaning that I have a bunch of sort of smaller terms here, and I want to put them all together, it's going to be the same sort of process, but in reverse. And to that end, I'm going to use the same sort of properties, right? So I have this log of a product is the sum. I have that log of the division is the difference. And I have that log of a to the b is b times log to the a. But there's one thing that's really easy to overlook, which is that these first two, the product and the division, these first two, they don't have any coefficients in front, okay? So it turns out that that's actually vital. That's actually really important. You can't do anything if you have a coefficient in front. So the first step we actually really need to use is actually this third property, because we need to take any coefficient, anything that's in front of a log expression, and sort of push it up as a power so that we can then sort of reduce to this case. We can then be able to use these properties now once we get rid of the coefficients. So to that end, we're going to use that log of a to the b equals b to log to the a, but we're using it in reverse, right? So we're looking for things of this form, b times log of a, so that we can put it in this form, log of a to the b, okay? So if we do that first, right, we take, for example, that 3, put it up as a power, so now we have log of x minus 1 cubed, right? Instead of having that 2 times log of 8x, I'm going to have log of 8x squared. Be careful, because it's not just, I'm not just putting the 2 on the x, right? It's the entire argument. So that 8x ends up being squared. So instead of getting, it's not 8x squared, it's 8x quantity squared, meaning I'd get 64x squared, okay? And likewise, if I have something like 5 log of y squared, right, that y squared to the 5th, right? So I'm going to have to multiply those in order to get them to one actual value. So once I've done all of that, then I can actually use my product and my division parts, right? Which again, I'm trying to go backwards. I'm trying to put stuff that's added together. I'm going to put those as multiply, right? So like, for example, here, these things are being added. So the internal pieces, right, the arguments are going to get multiplied together. This is being subtracted, so that's going to end up going in the bottom using our second property, right, and so on. So I'm going to end up with something that looks like this, right? So this is added, this is added, this is added. So each of those things become parts of the top using this first property. And then this thing is being subtracted, so that means that argument will be, right, the part that is subtracted, the minus log b, that goes in the bottom. So that argument, the y squared all to the 5th, that goes to the bottom. okay? So I can clean that up, right? The 8x quantity squared becomes 64x squared. The y squared to the 5th becomes y to the 10th. Other things stay the same, but that's my sort of condensed form at the end, okay? All right, so what did we do? Well, we went through and we talked about sort of how to expand or condense logs. And really the idea is to go basically from really big arguments down to little pieces that are sort of all being added or subtracted together, or likewise taking a bunch of little pieces, right, logs where they're all the same base, which is key. So they're all logs of the same base, and they're all these little pieces, and we can sort of push them back together and get one log with one big argument. And which of these is sort of the preferred form really depends on what you're trying to do with it. So in some cases, you want to break stuff apart because they might be easier to deal with. Other places, you might want to push everything together so that you get everything down to one term. And it really depends on what you're trying to do. Okay? So that is that.